so for a vector space, right, the vector addition and vector multiplication and scalar multiplication must obey all these 8 rules, right? First, it has to be commutative, then associative. There has to exist a zero vector that gives you back the original vector, right? There has to be a unique vector minus x that would give you a zero vector when you add it to your original vector. You multiply your vector by 1, you get it back, right? Multiplication again has to be associative. You could distribute the scalar on the addition, right? And you could distribute your vector on the addition of 2 scalars. So all these 8 rules have to exist, right, for a vector to be a vector space. And now in number 1 it's saying, let's say x1 x2 plus y1 y2 is defined to be x1 plus y2 and x2 plus y1 with the usual multiplication, cx equals cx1 cx2. Which of the 8 conditions are not satisfied? Well, let's check the first condition. What does the first condition say? It says x plus y. So I'm checking condition number 1. So if I add these two, I would get x1 plus y1, right? X1 x2, so this is x1 x2, let me do it explicitly, plus y1 y2, right? So what will we get here? You will get x1 plus y2. Why? Because they said so in the given. And comma y2 plus x2 plus y1. Okay, fair enough. Now let's do y plus x. Y plus x will be right, y plus x, so this is y1 y2 plus x1 x2. Okay, now according to the way they defined it, this is supposed to be the first with the second, so this guy goes with this guy, so this is gonna be y1 plus x2, and this guy goes with this guy, right? This guy goes with this guy, so that's x2 and y1. Yeah, so here we have x1 plus y2, or y2 plus x1. Well, does x plus y equal y plus x? No, they're not the same. They're not the same. So that means condition number 1 is violated. Condition 1 is not satisfied. You heard me? Hello? You there? Yeah, did you hear me explaining the question? Okay, checking the second condition now. 2. Let's see. So the second condition is x plus y plus z and x plus y plus z. Okay, so x plus y vectors, so this is gonna be x1 plus y2 as defined, and x2 plus y1. Okay, and then if we add z on this, so then x plus sorry about that. Okay, took my writing away. Okay, if I add the z on that, so this is x1 plus y2, x2 plus y1, and I'm gonna add on top of this z1 z2, z1 plus z2, assume. Okay, so the way addition is defined is you add the first with the last, so this will be x1 plus y2 plus z2, and the second one is x2 plus y1 plus z1. Okay, so this is x plus y plus z. Okay, let's check x plus y plus z vectors. Okay, let me use this different colors. So x plus, so y plus z will be y1 y2 z1 z2, and the way that this is defined, so this is x1 x2 plus, okay, so first with last, so y1 plus z2 and y2 plus z1. Okay, and now I operate with the defined law of addition on these. So the first, so now I'm doing x plus y plus z. So the first with the last, so x1 plus y2 plus z1, and the last is x2 plus y1 plus z1. Is this the same thing as the one above it? No, clearly not. So therefore 2 is not satisfied. Condition 2 violated, or let's just say not satisfied. Since these two are not the same, do not equal each other. Okay, let's go to condition number 3. Condition number 3, if I were to take x and I add 0 to it, vector 0, do I get x back? Well, let's see. x1 x2 plus 0 0, and the way this is defined as first with last, so x1, the second with first, x2. So yes, 3 is good. Condition 3 satisfied. Let's go to condition number 4. Condition number 4, which is, does there exist a minus x where when we add it we get 0? Well, let's see. So minus x will equal okay, so minus x will equal minus how's the vectors defined? X1 x2, so minus with the usual multiplication, so this will be okay. Usual multiplication, we just multiply the cn, so this will be minus x1 minus x2, so minus, so this is minus x minus x1 minus x2. And now the question is, if I were to add it to x, would I get 0? Well, let's see. We have x1 minus x1 x2 plus minus x1, so minus x1 minus x2. And if I operate with addition, again, the way the addition is defined, first with last, so I get x1 minus x2 and first with this, so this is x2 minus x1. So that means 1 second. But okay, so this didn't work, but that doesn't mean, because there could be something else that would make it 0. Well, let's think. We need something else to make it 0, so that doesn't mean this condition is not automatically satisfied. The reason being is because although this didn't work out, I didn't get 0 0. However, notice what happens here. If I switch the coordinates, meaning if I let minus x be minus x2 and minus x1, and now I add them, and now I do x minus x, what do I get? I get x1 x2 minus or plus minus x, so minus x2 minus x1. And notice now, if I add first with second, I get 0, and according to how addition is defined, and second with first, I get 0, which is equal to 0 vectors. So yes, this is satisfied. There exists an x where this is true. That's what condition number 4 is. So 4 satisfied. Let's go to 5. Well, 5 is 1 times x equals x. That's just from the fact, the way they define multiplication. You get cx1 cx2, so that's already, yes, that's defined since c. So since 1 x1 x2 will give you x1 x2, which is x, yes, satisfied. 6. Okay, number 6, it says, are there c1 and c2 where c1 c2 x equals c1 then c2x? Well, let's say there are. So let's say there are, and let's test it. So c1 c2 vector x, right, has to equal c1 c2. What's x? X we said is x1 x2, and now scalar multiplication is defined as is straightforward. So this is c1 c2 x1 and c1 c2 x2, right? Now notice I could rearrange this as multiplication as c1 c2 x1 and c1 c2 x2, all in bracket, and I could take the c1 out since multiplication is defined as it should be, c1 in algebra. So C1, and then I have left C2 x1 x2. So this is C1 C2x. Say that again. Right, number 2 turned out to be not satisfied. They're not equal. No, are you talking about 7 or condition 2? I'm still working. I haven't gotten to 7. Right, I didn't get to. I'm still on condition 6. Okay, let's do 7 now, since my student here is rushing. Seven, he's just asking, so this doesn't count as explanation what he's saying. So cx plus y. So let's see. So we need to see if there's a scalar. We need to see if there's a scalar where it distributes. Okay, so we know that x plus y is x1 y1, x2 y2, and so this becomes first with second according to how addition is defined, y1 plus x2. Okay, now if we multiply c in there, so cx plus y will be c x1 plus c. So I'm distributing c on the last one since multiplication is defined straightforwardly distributive, and c y1 plus c x2. Okay, fair enough. Let's see if the other one turns out to be the same. Now we need to check the right hand side of 7, which is cx plus cy. So let me use a different color. Cx plus cy. So this is c x1 I messed up here. Apologize. Wait 1 second. This is x2 y1 y2 x1 plus y2. Surprisingly the same answer because they're swapped. Okay, so luckily that didn't affect the answer. Okay, so now going back here, so this is x1 x2 plus c y1 y2. So according to how multiplication is defined, I distribute the cx2 plus cy1 cy2, and now according to how addition is defined, this is first with last cy2 and second with first, and this is exactly equal to this guy, so they're equal. So yes, condition number 7 is satisfied. Okay, let's go to 8. The last one is 8. C1 plus C2x equals C1x plus C2x. Okay, well, let's see what C1 plus C2x is. Okay, going down to the bottom here. So number 8, condition number 8. So c1 plus c2 vector x equals c1 plus c2 x1 x2. So this will distribute because multiplication is defined as distributive. So c1 plus c2, so I could distribute the c1. Let me just do this in one step. So c1 x1 plus c2 x2 and c1 x1 and c1 x2 plus c2 x2. Okay, let's see what c1 x plus c2 x is. So this is c1, whatever there's an x, I put x1 x2 plus c2 x1 x2, and I could distribute the c. So this is c1 x1 c2 x2 c2 x1 c2 x2. So plus here. Okay, and then the way the addition is defined, that is first with last. So c1 x1 plus c2 x2 comma, and then last with first. So c2 x2 sorry, this is supposed to be c1 x2 plus c2 x1. Okay, do these two the same? c1 x1s? No, they're not the same. So these are not equal, therefore 8 is not satisfied. Okay, so there were 3 conditions not satisfied: the first, the second, and the last.